All right. So we've talked, or we saw quadratic motion, as I called it. And the reason I want to point out this section is if you look at your homework questions, they will specifically ask you to graph the vertex and graph an intercept, which means they'll take any intercept, the y-intercept or some of your x-intercepts. But in order to find those quickly, you're going to need to really get used to this vertex form and how to move from the vertex. Now we did that once, but let's do it again. And let's say when a equals 1, here's your vertex wherever it is on the x-axis. But from there, let's draw this out. If I move right 1, I move up 1. If I move right 2, then I would move up 2 squared. And so then from there, if I moved right 3, you guessed it, you moved up 3 squared, which is of course 9. And that's how quadratics get this shape, is because of that squaring. Now on the other side, remember that I'm a lazy mathematician, so I didn't write parentheses because I knew they would square and be positive. But over here, from the vertex, if you move left 1, now's where you need to carefully write them in parentheses. Because you would, sorry, let me write it so I have space here. You would square that and still move up 1. That's why this gets, a symmetric shape, is because that negative, when it's squared, turns positive. If I move left 2, then guess what? You just squared -2 and still went up 4. So there is what I am referring to, and sorry that this is like cutting off into it, but that's okay. That's what I'm referring to quadratic motion. So from your vertex, right 1, up 1. Right 2, up 4. Left 1, up 1. Left 2, up 4. And so maybe I could just say it out loud and you could think of the answer. If I move right or left 5, you should know how much we move up. And the answer is 25. Now, we're not really ever going to graph that, but just to say, from your vertex, if you move right 5 or left 5, you would square and move up 25. So there we go. Now, the one last thing we need to cover is what happens when a is not 1. Well, then there's one additional step. Here's your vertex. We'll have to do this with extra space. So now 1 is scaled to look a little wider. What you end up doing here is you take a times 1 squared. And if you went right 2, then it's a times 2 squared. So that a in front from that vertex form multiplies the thing that makes it squared. And guess what? That a in front then multiplies after you square. So same thing over here. This would be a times -1 squared, which would still just be the same result here. So it's the same result. That's why it has an axis of symmetry. And from there, again, if you go left 2, then you just multiplied a times -2 squared, which is the same as over here. So hopefully, again, that idea makes sense that this is a quadratic. It squares things in its formula. So when you move right or left from the vertex, that amount gets squared as vertical motion. And if there is a number out front, a, you multiply that after you've squared the left or right motion, so to speak. Okay, with that being said, and this video is going to be a little shorter because we're just going through these 3 examples, let's see how we can figure out these graphs by hand and then make sure that we grab an intercept to plug into our online homework. So this graph, I'm going to go really, really quick here, moves right 3 and down 5 for its vertex. So right 3 and down 1, 2, 3, 4, 5 in its vertex. There we go. Okay, the one other thing I need to ask myself is now, what's this number out front? Well, this number out front is 1. So this is standard quadratic motion. So from my vertex, I will move right 1 and go up 1. I will move left 1 and go up 1 because after all, there is an invisible axis of symmetry cutting through the vertex. From my vertex again, if I were to move right 2, I would square that and go up 1, 2, 3, 4. There we go. And that would get mirrored on the other side. If I went right 3, I would go up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I went left 3, I would go up 1, 2, 3, 4, 5, 6, 7, 8, 9, because after all, it's symmetrical. Oops. And so there's my quadratic. All right. Now, your homework again is going to say plot the vertex and an intercept. Now here's what I want to point out to you. These intercepts on the x-axis are not nice and clean. They are definitely only going to be found by using the quadratic formula. That's why they don't cross cleanly, is because somewhere there's a square root that didn't simplify and give you nice clean numbers. Fun fact there. So now you know a little more. But there is an intercept you can use, because take a look at this. There's your y-intercept. So for your online homework, if this was your example, you'd have to graph your vertex, and you have to go with the y-intercept because it's the only valid, or I guess graphable, easy intercept to place on the grid. So your choice is kind of forced in this example, if you kind of hear what I mean there. Let's look at the next one. Now, finding your vertex, again, the x value flips and the y value stays the same. So from the origin, I went left 4, because it said positive on the inside, so it flips, so left 4, and then up 4 because that's as is. All right, here's my vertex, and now what am I going to do? Well, A is not 1. When I do my quadratic motion, I'm going to have to multiply a negative to my results as I normally would. So what do I mean by that? Usually, I would go right 1 and square up 1, but instead I'm going to right 1, say I would go 1, but then negate that, so it'd be right 1, down 1 instead. This graph is perfectly flipped downward instead of upward. There's just a single negative, so not crazy stretching or anything, but instead of going up, it's going down, a negative multiplied after. And so again, that's mirrored. All right, again, I should be going right 2 and up 4 according to the normal motion, but now I'm going to go right 2 and down 4 because of that A being -1 out front. At this point, take a look. I've found the point I definitely need, and I've found two intercepts right there. I could choose either one to use in my online graphing tool. Your y-intercept, I'll go ahead and tell you, is not going to be able to be like chosen as a graph unless they scale this for you on the option, because your y-intercept isn't going to occur until, let's think about it. I would move right 3 down 9. I would move right 4 down 16. So if we were at 4 and we went down 16, your y-intercept's down here at -12, but we're not going to bother to write that in. So the point is, this time it was the x-intercepts that landed perfectly, which again, if you didn't catch this, means your quadratic formula, if you expanded this all out and did it, would have worked out. The square root would have actually been a perfect square and gone away. That's why it crosses nicely, just so you know. All right, one more example. Here we go. This vertex went right 2, down 7, right 2, down 7. And this time I've got a vertical stretch of 3, but not a flip. So what does that mean? Well, usually, again, I would go right 1 and up 1, but now I'm going to move right 1 and go up triple the amount, so 3 instead of 1, which means I could go left 3, or left 1 and up 3, because again, there's an axis of symmetry. But here's our vertex, just to denote that. Now, again, usually I would go right 2 and up 4, but now I'm going to triple that motion because of the 3. Instead of going right 2 and up 4, I'm going to triple it and go right 2 and up 12. So goodness. Right 2 and up 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Sorry, that's just how I was thinking about it. Um, Up 7, and then 5 more gets me to 12. Sorry, I thought that in my head and then didn't explain what I was doing until I said 7 and then 5. But 7 plus 5 is 12. Anywho, what does that do for me here? Well, once again, it means that if this equation was expanded out and we tried to factor it, it wouldn't factor. We would need to do the quadratic formula, and that square root wouldn't work out nicely. Hopefully you're hearing that argument, and that's why, again, these x-intercepts are on the graph, but they aren't clean, nice grid answers, so can't use those. So once again, your hand is forced. You would need those 2 points to graph. But here's the big lesson here to close out 3.1. This point was so easy to find once I memorize quadratic motion, right one up one, right two up four, or really I should say any movement one is up one, any movement two is up four, but does that up four or up whatever need to be scaled by a number or negated or scaled and negated, right? There could be a -4 out front, and that would just multiply after the motion you determine. So hopefully that clicks and you get used to, again, quadratic motion, and I'll see you in 3.2.